Hey everyone, I'm Chanakya. So you know how Python is great for AI and web apps, right? So, but the moment it talks to databases, it suddenly feels slow. Especially with MariaDB, one of the fastest databases out there. Python somehow becomes the bottleneck there, and that's the real issue I wanted to dig into. Most of the MariaDB connectors which are available right now there in the market are still synchronous. That means every query blocks your entire application, which kills the concurrency and which wastes our CPU time. In APIs, background jobs, or ML pipelines, that's a real pain. And you're waiting on queries when your system could be handling thousands of other tasks. So that's where my journey started, fixing the gap between Python's asynchronous world and MariaDB's performance. Now let's talk about the problems, the bottlenecks in Python and MariaDB. Python's existing MariaDB connectors are synchronous, which blocks our entire application. So next, data handling is manual and repetitive. Converting results to pandas data frames is just lines and lines of boilerplate code. And bulk operations, when it comes to that, inserting thousands of records is painfully slow and unoptimized. Finally, AML teams like us who work with embeddings or rack pipelines spend hours writing custom pooling and retro logic. This is what the scenario. This is how it goes. And all of this makes MariaDB integration feel outdated for the modern applications today. So that's what I felt when I worked with it previously. So that's where asynchronous MariaDB connector comes in. And that's the bridge I felt there. What's the solution? I designed this connector around five solid principles. First one is asynchronous with connection pooling, which is built on top of Async and AO MySQL, and which is for truly non-blocking performance. The second pillar is which is resilient by design, which means automatic retries, exponential backoff, and structured logging using tenacity. So even though whenever database failure occurs, it survives through it. Proper logging, precise error handling, everything happens here. The third pillar is seamless pandas integration. Fetch results directly into data frames, insert data frames directly into the tables. This is what the pillar is. And the fourth pillar is memory efficient streaming. Process millions of rows safely without memory overflows. This is what its function is. Finally, the AML optimization, which is native JSON embedding support, perfect for LangChain and vector storage systems. Yeah. Now let's move on to the API overview. Everything you get out of the box. Simple query functions here are execute many, fetch all, fetch one, and fetch stream. The fetch stream one is memory efficient streaming for large data sets, and execute many is batch operations, multiple parameters. Parameters can be set, parameter sets. When it comes to the data frame integration APIs, you get fetch all DF, bulk insert. Direct query to data frame conversion happens with this fetch all DF, and high speed data frame to database inserts with the bulk insert. For the connection management, you get connection, release connection, get pull stats, close. We should specifically talk about this get pull stats. You get complete monitoring here, size, invoice available. You get these clear stats here. And everything runs inside a context manager. So no manual connection management. You need not manage anything. Okay. We can deliver projects clean and fastly. So we also had proper error handling here. You can just directly use the environment files to just set the port number, DB name, and password. That's it. You need not manage anything manually. So here's the sample code, which uses our API, db.execute many. So with a single operation, you are able to insert into DB. So now let's go to the live benchmark. So this is for synchronous versus asynchronous performance comparison. So here's where it gets interesting. I ran a live benchmark comparing the official synchronous connector versus Async MariaDB connector. So for 10,000 inserts, asynchronous finished in 0.292 seconds, slightly faster than synchronous. For 100 concurrent reads, asynchronous shaved off more time from 0.183 to 0.162. So it may look small, but for continuous parallel workloads, that's a massive gain in throughput and responsiveness over the time. Now let's talk about the before and after benchmarks. The concurrent reads at like for 50 tasks we perform, it speed up using the existing libraries and the current asynchronous MariaDB connector. The concurrent is like 1.76 times faster, and for the bulk insertions and data frames, it's 1.0101 times faster. As we keep on increasing the input, we will be able to see some more improvement in the speed up. So beyond the raw numbers, the real advantage is connection pooling, cutting open connections like 40 out of 15 concurrent tasks. So you get faster performance and lower resource usage with 70% less code. That's where. Now let's talk about a simple example. Let's suppose here's the code. A real world case, building a LAN chain RAG system using MariaDB. So without asynchronous MariaDB connector library, you're looking at 60 lines of nearly 60 lines of code, boilerplate code, manual connection you're going to create here, manual commits, error handling, JSON serialization, custom similarity logic, everything you need to mention specifically everything. The thing is, it works fine, but it's very heavy, fragile, and not production friendly. So now here's the same system, same use case written with asynchronous MariaDB connector. Just you need to import it. That's it. Just 20 lines of code. Nearly 20 lines of code that are clean, readable, and production ready. So automatic pooling, a bulk insert, and a single use with bulk insert thing. You'll be able to do it here. Data frame friendly queries. You'll simply get fetch all data frames. It's not just shorter. It's reliable and scalable for the AI pipelines which we develop. Now future comparison. You can see that lines of code for the specific example, it's reduced very much. Connection handling, it is manual without this async MariaDB connector. Here it's automatic. There's no connection pooling without our connectors. You need to manage manually. And there's a built-in pooling with our connector. Error handling, we had automatic error handling. Bulk insert, you can directly do it single method without no loops. There's a data frame support, inbuilt data frame support, and simple and clean. You can maintain it simply, no complex maintaining. To summarize, 67% less code, faster development, built-in connection pooling, which is memory efficient, fast bulk operations, pandas integration, automatic retries, logging, and monitoring. It's a production ready, AI ready, and developer friendly, all in one package. Async MariaDB connector. That's what you get. So, why use this over others? We had PostgreSQL available out there, MySQL available out there. Why can't I use those? Why should I only choose MariaDB? MariaDB is like 13% faster, and JSON queries are 33% faster for full text search. And MariaDB is open source and community driven and not controlled by some other. And why should I use my library as in MariaDB connector, which is going to be our library, and why not existing AU MySQL ones? Why? Because you get connection pooling, data frames, bulk operations, and retail logic built in, which are essential for the modern applications. Simple, easy, fast, production ready, faster shipping. That's what we get. So what are you waiting for? What are you looking for? Just make your applications faster, simpler with this pip install async MariaDB connector. That's what you get. So you can also view complete info, code, everything about my open source contribution here at this particular link. I'll provide you this page. And signing off. Thank you.